T be an operator which is defined on a certain space and defined in this way: Tg is equal to h, where h is the right hand side of the integral equation. Thus, showing that the above operator equation has a solution is equivalent to showing that differential equation 1 has a solution. As we discussed in previous slides, we convert differential equation into other form of equation which is operator equation, and the solution of that operator equation is actually the solution of our problem. There are also many problems which can convert into operator equation. Tx is equal to x is the equation. The point x is called fixed point of this operator equation.
नहीं,
Solving a fixed point problem.
दिस ऑपरेटर इक्वेशंस का नाम है, दिस ऑपरेटर के है ना?
This operator, the
हाँ,
fixed point of this operator.
इसको इसको बेस्ट वे ये आप इसको रीड ही कर लें, एलिमेंट इज कॉल्ड फिक्स पॉइंट ऑफ दैट ऑपरेटर इफ x remains invariant under the action of t. इसको ऐसे रीड कर
Yes,
लें.
sir. And an element x belongs to it is called a fixed point of operator t, where x is a point which is invariant under the action of t.
जी.
Solving a fixed point problem is to show that a set which is a collection of all fixed point of t which is non-empty. In this example, we see how fixed point can solve some different problems. For example, we have a polynomial equation and we are interested in finding the solution of polynomial equation. To solve this problem, we can convert this problem into the language of fixed point problem as follow. If we define the operator z is equal to z plus pz, notice that fixed point of this operator is the solution of this equation. Existence of fixed point revolve around the condition on domain and operator t. Under what condition that t has at least one fixed point? This theorem is known as existence theorem in analysis. So first ever solution of fixed point problem in metric space is given by Stephen Banach. In 1922, we state that every Banach construction in a complete metric space has a unique fixed point. Well-known fixed point theorem. Canaan construction. This construction is said to the Canaan construction. Riesz construction is the combination of Banach construction and Canaan construction. So the combination of Banach and Canaan are said to be the Riesz construction. It was proven that every Canaan construction and Riesz construction defined on a complete metric space have a unique fixed point.
अच्छा, यहाँ पे ये
Next
बताएं कि ये m+2 के स्ट्रिक्ट लेस देन की जो कंडीशन है ये क्यों लगी हुई है? m+2 के स्ट्रिक्ट लेस देन
क्योंकि हमने बनात और केनान का ये कॉम्बिनेशन है, तो क्योंकि हमारे पास जो अगर हम बनाक देखें, ये हमारे पास बनाक कॉन्ट्रैक्शन, इस पे हमारे पास जो कांस्टेंट था वो 0 और 1 में बिलोंग कर रहा है, और जो केनान है उसमें हमारे पास 0 और 1/2 के बिटवीन है। तो इसलिए हमने इसमें m+2 के जो कांस्टेंट है उसको हमने लेस देन 1 कहा हुआ है।
ये तो कोई रीजन नहीं. ये कोई रीजन नहीं. आपको पता नहीं है कि ये कांस्टेंट के ऊपर जो कंडीशंस लगाते हैं ये आगे जब प्रूफ करते हैं क्या चीज ये हेल्प करती है?
जब हम इसमें वो कोशी प्रूफ कर रहे होते हैं उसमें हमारे पास इस तरह का।
हाँ, तो ये रीजन है एक्चुअली कि जब हम वो सीक्वेंस पिकार्ड इटरेशन कंस्ट्रक्ट करते हैं तो उसको काशी प्रूव करने के लिए जो कांस्टेंट अंदर चलते हैं वो ये कंडीशन होती है, तो वो लेस देन एप्सिलॉन होता है.
यस सर,
ये सब की ये रीजन है.
यस।
नेक्स्ट.
Next section is about operator enrichment technique in Banach space. So here we need the concept of average operator, where T is a map from X to X. An average operator is defined as T lambda and defined as follow, where X is defined as follow, which is the convex combination of X and Tx. Clearly, fix of T lambda is equal to fix of T. Brinde and Packard generalized the Banach fixed point theorem by introducing the concept of enriched Banach contraction in the setting of Banach space. Brinde
नहीं,
and Packard's finding.
बैक जाए बैक। इसमें आप ये लाजमी बोल रहे हैं कि ये इस प्रॉपर्टी की वजह से इसको कीपिंग इन माइंड कि फिक्स ऑफ टी और फिक्स ऑफ टी लैम्डा क्योंकि सेम है, देन इस बेस्ड पे उन्होंने बना फिक्स पॉइंट को जनरलाइज किया और उसकी आगे कॉन्ट्रैक्शन दी। ठीक है।
Yes, sir. Yes, sir.
नेक्स्ट।
Brinde and Packard's finding. So this contraction is said to be the enriched Banach contraction, and this contraction
ये
is said
थोड़ा
to
सा
enrich
थोड़ा सा रीड तो करें उसको क्या है?
in a norm space and a
या
mapping T from X to X. A mapping T is called enriched Banach contraction, and this mapping is said to be the enriched Canaan contraction.
नहीं, यहाँ पे
Enriched Siric,
पीछे यहाँ पे जस्ट थोड़ा सा और कमेंट करें कि यहाँ पर ये वाला जो फैक्टर है ये एक्स्ट्रा फैक्टर है, बी ऑफ एक्स माइनस वाई, क्योंकि पीछे टी एक्स और टी वाई था ना,
yes, sir,
तो जस्ट ये
where
फैक्टर
Bx,
एक्स्ट्रा रखा हुआ है। हाँ,
yes, sir.
ये इसीलिए उसने इस तरह डिफाइन किया है ताकि जब वो बी की वैल्यू पुट करेगा तो देन ये चीजें टी लैम्डा टी एक्स और टी लैम्डा वाई में रिड्यूस होगी।
Yes, sir. Uh, in
नेक्स्ट।
In a norm space, a mapping T from X to X, a mapping T is said to be enriched Banach contraction, where B X minus Y is extra factor. If we put the value of lambda, it will transform into the T
नहीं
lambda
नहीं, यहाँ
X
पे
and T lambda Y.
ये जस्ट मैंने आपको बताया है, इसको आप
X,
ऐसे उसको
yes,
पढ़ेंगे, ठीक।
yes, sir. Enriched Siric contraction. Enriched Siric contraction is the combination of enriched Banach and enriched Canaan contraction. From the above definition, we concluded that Banach contraction and Canaan contraction are independent of each other, and we concluded that enriched Banach contraction is a generalization of Banach contraction, enriched Canaan contraction is a generalization of Canaan contraction, enriched Siric-Riesz contraction is a generalization of Siric-Riesz contraction, and enriched Canaan contraction. Brinde and Parker's finding. In a Banach space and mapping T from X to X be an enriched Banach contraction, enriched Canaan contraction, enriched Siric-Riesz contraction, then T has a unique fixed point. The requirement of m plus 2k less than 1 in enriched Siric-Riesz contraction defined on a complete metric space have a unique fixed point. This naturally prompts the question, what happened when the remove the condition of constant such that m plus 2k less than 1 in enriched Siric-Riesz contraction? Does it leads to the same conclusion as stated in this Siric-Riesz contraction? To answer the question posed above, we require the following concept of asymptotically regular. So, in a norm space, an operator T from X to X is called asymptotically regular if this mapping is satisfied, if this condition is satisfied. Answer to aforementioned question is given by Gronsky and Bisht in Journal of Fixed Point Theory and Application in 2021. Next section is about asymptotic regularity of generalized average mapping in MK-SIHR Siric-Riesz contraction. Let us start with notation and facts. In a norm space and a mapping T from X to X, where OM donate the set of phi from X to R, where phi of X is not equal to 0, and omega donate the set psi from X to R, where psi of X is not equal to -1. The generalized average operator is donated as T phi. Generalized average operator is denoted as T phi and defined as follow.
इसको पढ़े ना ये
By taking
लास्ट टाइम भी
phi of
फाई
x
को।
is equal to lambda. Taking phi of x is equal to lambda, we see that t lambda is equal to t phi. It's mean that average operator and generalized average operator both are equal.
फॉर दिस
Fix
पर्टिकुलर
of t
वैल्यू
is
ऑफ
equal,
फाई।
yes, on this particular value of phi.
हाँ,
If fix of t is equal to fix of t phi, now here
यहाँ पे पास
our main
पास
result,
खत्म नहीं किया आपने।
sir,
नेक्स्ट।
sir ये यहाँ से मेरा पूरा है.
चलो ठीक।
Here we pose the following concept of HS Siri-Riesz contraction. In a norm space and a mapping T from X to X, a mapping T is said to be MK psi HS Siri-Riesz contraction. This paper is published in
नहीं
Carpenthian.
नहीं, इसमें आप इसमें बताए ना आपके एम और के कांस्टेंट है और साई आपका उसमें से आ रहा है और ये कंडीशन सेटिस्फाइड हो रही है, एक्स आई ऑफ एक्स प्लस डी एक्स ओवर वन प्लस आई ऑफ एक्स। थोड़ा सा इसको ठहर के बताना क्योंकि ये मेन डेफिनेशन।
HS Siri-Riesz type contraction. In a norm space and a mapping T from X to X, a mapping T is said to be MK HS Siri-Riesz type contraction if there exists MK greater than 0 and psi belong to omega such that x psi x plus tx over 1 plus psi x minus y psi y plus ty over 1 plus psi y less than or equal to m norm x minus y plus k norm 1 over psi x plus 1 into x minus tx norm plus norm 1 over psi y plus 1 into y minus ty norm for all x y belong to x. In a Banach space and a mapping T from X to X via MK psi HS Siri-Riesz contraction, assume that there exists phi belong to omega such that T phi is continuous asymptotically regular mapping and T has a unique fixed point where phi of x is equal to 1 over psi x plus 1 for all x belong to x. So here is the example. Consider a mapping T from R to R defined as Tx is equal to 2x minus 3 for all x belong to R. So T does not satisfy enriched Banach contraction. T does not satisfy enriched Canaan contraction. T does not satisfy Siri-Riesz contraction, BMK enriched Siri-Riesz contraction, but T satisfy MK psi HS Siri-Riesz type contraction. Take psi of x is equal to minus 2 for all x belong to R and T is continuous. T is not asymptotically regular additionally for any lambda. T lambda is not asymptotically regular. On the other hand, if we take phi of x is equal to minus 1, notice that for all x belong to R, we obtain that T phi is asymptotically regular. If psi of x is equal to 0, in theorem 5, we deduce the following result, which is given by Gronsky in Journal of Fixed Point Theory and Application in 2019. If psi of x is equal to b, for all x belong to x, we have the following result, which is given by Gronsky and Bish in Journal of Fixed Point Theory and Application in 2021. So here is a question, does removing the asymptotic regularity condition from theorem 5 lead to the same conclusion as stated in theorem 5? To investigate this, we now proceed to establish the following result. In a Banach space and a mapping T from X to X via HS Siri-Riesz contraction, then T has a unique fixed point provided that m plus 2 k less than 1. In special case where psi x is equal to 0 in theorem 7, we deduce the result established in 1971 by Siri-Riesz. In particular scenario where psi x is equal to b, in theorem 7, we obtain the following result. If we take m is equal to 0 in trolley 5, we obtain the following result, which is BK enriched Canaan contraction. As a special case of corollary 5, we deduce the main result where X not be a Banach space and mapping T from X to S if there exists B belong to 0 infinity and M dash plus 2k less than 1 such that for all X y satisfy this construction, then T possesses a unique fixed point. As a special case of corollary 5, we reduce the main result into M R canine type construction. So next section is about application to activation function through fixed circle problem with enrichment technique. In some special metric space, mapping with fixed point have been used in neural network as activation function. For example, Mobius transformation have been used for this purpose. So Mobius transformation has at most two fixed points. Mendick observed that fixed point of a neural network were determined by fixed point of the employed activation function, as we see in this paper. Now let us consider the following self-mapping T1 and T2, which is defined as. So the fixed point of the set T1 is fix of T1 is equal to 0 and fixed set of T2 is fix of T2 is contain all the x which is greater than 0. Also these mappings T1 and T2 are activation function as we see in this paper. Now question is, what are the geometric properties of fixed point in which case self-mapping has more than one fixed point? A new light to fixed point theory geometric thinking, the above question have been defined as fixed circle problem when the self-mapping T from X to X has more than one fixed point. So in a metric space, circle is defined as the collection of all point having distance from center equal r. And fixed circle problem, if Tx is equal to x for every x belong to the circle, then Cx naught r is called the fixed circle of T. Oscar and Tas finding in 2017, Oscar and Tas initiated the study of fixed circle and proved the result of Riesz type construction on a metric space. Notice that C1 granted that Tx is not in the exterior of a circle. Similarly, C2 granted that Tx is not interior of the circle. From here, our main results are stars. Following the idea of Brinde and Parker for the construction of new contractive condition in the literature of metric fixed point theory, we generalize fixed circle theorem of Oscar and Tas finding as follow. In a norm space, a mapping T from X to X assume that there exists B such that the following conditions are satisfied C1 and C2, then Cx naught r is said to fixed circle of T. We investigate new solution to the fixed circle problem. To do this, we use the following two number in a norm space, a mapping T from X to X. So we use these two number RT Bx x naught and QT B x naught x. Fixed circle problem for bilateral type construction. If there exists a function psi from x 0 to infinity and the element x naught belong to x and there exists a value b such that if this mapping is said to be the T is called B x naught side journal Jagged bilateral contraction. T from x to x be a journal Jagged bilateral contraction and R is defined in this way. So T fixes the circle provided that T x naught is equal to x naught. Fixed circle problem for the Gupta bilateral type construction. If there exists a function psi from x 0 to infinity and element x naught belong to x and there exists a value b, so this type of contraction is said to be the journal Dasgupta type bilateral contraction. Let T from x to x be journal Dasgupta type bilateral contraction and R is defined as, then T fixes the circle provided that Tx naught is equal to x naught. This example of mapping T is defined in this way. We satisfy our theorem. So Tx and psi x, if we take b is equal to 1, then lambda is equal to 1 by 2. In this case, we obtain t 1 by 2x. Moreover, contractive condition 5 reduces to 6. And rt1xx naught is equal to this. Clearly, T is a 1-0 side general Jagged-type bilateral symmetric contraction, and R is equal to 1 by 2. This satisfies the condition of theorem B. Consequently, T fixes the circle. Next is the application. Activation functions are imported in neural network as they facilitate learning and interpretation. Their primary function is to transform the input signal of a node into a neural network into an output signal. There are numerous examples of activation function being utilized in neural network, with rectified linear unit being one of the most widely used activation function. Now we consider the following function Tx. Note that the average mapping is rectified linear unit activation function T lambda x.
नहीं, यहाँ पे आप रुकिए, इसमें ऊपर आप ये कमेंट करें कि हमने ये एक ऐसा फंक्शन कंस्ट्रक्ट किया है कि जिसका जो एवरेज मैपिंग है वो हमारे पास एक एक्टिवेशन फंक्शन है, ठीक है,
Yes, sir. Yes, sir.
रेक्टिफाइड लीनियर यूनिट।
Yes, sir. Average mapping is we construct the function of average mapping, which is activation function. Suppose x0 is equal to 1, the function psi from x to 0